And afterwards, we have some 1D element problems. So basically, here we will be having two-dimensional elements, and here we are having one-dimensional elements. And these cases are important in case of such bar competitions. So where you need to do such calculations and maybe preparation of some reports on such calculations. So here we will be seeing those cases, and yes, we have that much for today. So no need to go into theory part for today, because as we have seen various calculations, so it's similar to that. Just here, addition will be this one. So selection and creation of like a 1D element and defining 1D element. So that part will be new over here. So let's see one by one, like how we can calculate these things. So just go on to workbench. So we will first solve this disk break problem, and afterwards we will go on to this bar roll cage. Right. So let me check whether we have same count, or still we are same. So we can't actually wait because we already passed half an hour. Okay. So maybe I'll save it first. Let's go to an assignment. Maybe I'll section number 7. Okay. So let's check the input data. So perform static analysis on break disk by using different loading conditions. Loading will be pressure on the like where I'm having my caliper pads on outer diameter basically, and fixed support in this bolting locations. Okay. So what I need to find out: stress, deformation, and reactions. So this part is a little bit new. Reaction forces due to input geometry. So yes, let's see. First of all, I'll go to the static structural part. So simply I'll double click it over here. Maybe I write problem one way. So material is structural steel. That's fine. My units are already set. So just go on to the design modeler. And here, yes. So just go on to the plane, check the unit, set it to millimeters, and let's just import the model for the disk break. So file is over here. Yeah, disk break. So yes, so here I got. So you can see over here. So this is only a surface body. So these do not have any thickness across. So this is the surface body, and here you can see it is mentioned as surface body, right? So basically, we need to define some thickness for this. So here now it has mentioned that it is 0. So maybe here you can say a user defined, and maybe you can just put 10 millimeters. What I did, I just defined the thickness for this. Right. So now just go to the, now click on the model and just enter into the mechanical. So there you can cross check this part. So here I haven't defined the material because it's structural steel. So I only made like two moves. One is like I imported model in design modeler. And second is I assigned a thickness, right? So just go over here and check. So here I can see that thickness, which is nothing but 10 millimeters, right? Now I simply right click it over here and say mesh. Maybe we'll just check whether we have anything related to mesh. Okay, right. But as I check it over here, you will say me like I'm seeing element like this, maybe uh, of 3D size, but in reality I am having only surface body. So those elements are only for my visualization purpose. So maybe here somewhere you can see offset. So offset is middle, means if I just go on to this, so you can see some dotted line in the middle. So if I move just cursor to this location, so I'm having my surface body in that location, and I have defined 10 millimeter as a thickness. So 5 millimeter on upside and 5 millimeter on downside. So I am having my surface body exactly at the mid plane. That's why here it has shown, it has written like offset type as middle. So I can change this also, like I can move it to top. Maybe if I go to mesh, then it will just move to top side. Now you can see it. Same thing I can do, means top, bottom. So best way is to calculate at middle, or I can have like user defined one, maybe 2 millimeters from top side, but it will not have any impact on my results. So just keep this point in mind. So whatever I change it over here, this will not have any impact on my results because I'm having a surface body. So whatever will be calculating, it will be calculating on my this surface. So maybe for example, if I am having a result maybe X, and my plane is at mid side, like at offset type is middle one, and that X value basically the software shows me only for visualization at 5 millimeter in top side and 5 millimeter at bottom side, means it just transfers those values at some distance. So distance is basically half of this thickness what I have defined. So that's what it performs. So this is only for your information. This is nothing to do with our today's calculations, but just for information I shared this with you. Now I have meshed it, and this mesh is only for visualization. In reality it has only 2D elements in it. So only if I'll say this one, so only it is having these elements and they do not have any thickness. Fine. So now go with over here, say insert and say pressure. So I have to apply pressure. See, means when I selected somewhere here, it has taken this face because due to that offset type middle, it has taken the face, this face. So I just selected this face, and maybe we will apply the pressure. Let's check what value we have. It's 10 megapascal. So I simply write 10 over here. And secondly, I need to fix the holes in the middle. So what I do now, I just go to edge selection and I select these edges. So one, I hit control, two, three, and four. Fine. Go over here and say fixed support. Just right click and say sort. Now I want calculate deformation. I'll say total deformation. Let's calculate stresses, equivalent stresses. So these two results, they are well known to us now. So I'm having fixity in the middle. That's why everything is in blue color. And here outside I'm having the pressure. That's why it is deforming. So same thing you can observe here in the form of stresses. Fine. Now just go on and check what other parameters I need. So here reaction forces on the geometry due to input loading condition. So what is my input loading condition? That is pressure. So which is acting on this face. Right. So what basically a reaction I'm getting? So reaction forces on these four holes which I have fixed. So in that case, now you can do it by two ways. Either you can just simply click on this fixed support and drag it and drop it over solution. So it will directly create a force reaction for you. Right. Or second option, maybe just evaluate this first. So by this, you can come to know, maybe you can see this Z direction and you can see. So this is your reaction, whatever you are getting it over here. And second way to do this same thing, to calculate this reaction, just right click here on the solution, go on to insert, go on to the probe, and here you have one option, force reaction. Right, go into insert, right click, say insert, go into the probe, and from then you go to the force reaction. And here you need to select the boundary conditions, on which boundary condition or which support you need this. So on fixed support I need it. So just say right click and say evaluate. So same thing you will get by this fields. So both the results are same. One is just to drag and drop, and second is go to insert, from insert go to probe, and then to force reaction. Fine. So that's it. So we have completed this first problem. This is simple, and we did like such problems many times until now. So maybe we did such things, 3 4 times. That's why here I am a little bit faster. Then we will have maybe some more time for other like bar kind of calculations. So that's why here I am a little bit faster. Now, so the only change here, so I'm having exactly similar geometry, I'm having exactly similar pressure, but in addition to that, I'm having a rotational velocity on the disk. So what that is 80 millimeter per second square in Z component direction. So I'll assume here Z component is perpendicular to my disk. Again, same thing, fixed support is on that holes, and same output basically I need to have. So here, if I'm having exact like all the inputs exactly similar, so now what I will do, instead of creating new model or new calculation, I'll simply drag this and put it on this on model, because I'm having my material same, I'm having my geometry same, even I'm having my mesh or everything is same. So only change is in my boundary conditions and results. So that's why. So everything I have shared it from my A group. Okay. So if I just double click it over here, so I will have, so you can see it from here. So this is my first calculation shown by A5, and here it's B5. So this will be my second calculation. But apart from this, so mesh, coordinate system, geometry, so everything will be common for these two systems. So mesh will be common for these two systems. Whatever coordinate systems I am having, basically this global coordinate system, that will be common for this. Even geometry, all the geometry parameters like thickness and all material, so everything will be common for these whatever calculations I'm adding afterwards. Right. So I am having a fixed support which will be exactly similar. So what I will do, I will simply drag it and drop it over here. Second is pressure, that is also exactly similar, so I just drag it and drop it. So in addition, now I am having rotational velocity. So maybe just check, right click it over here, go to insert and add rotational velocity. Let's see where it is. So here it is, rotational velocity. But to define this rotational velocity, I need to have some axis. So maybe, so this disk is rotating. I'll just click on Z axis. So this is my Z axis. So perpendicular axis is my Z axis. So this disk is rotating uh, uh, across that Z axis, means My axis for rotation is Z. So here basically I am having coordinate system which is Cartesian one. Can you see? So X, Y, Z. So these are my Cartesian coordinate system. So what I need to define additionally over here, I need to define one cylindrical coordinate system which will have my one of the component which will be rotating. Right. So simply what you can do, you can simply go to here, insert coordinate system. So instead of Cartesian, you just make it to cylindrical. So for geometry, you just click on the geometry and maybe you can select any circle. So can you see here? So you have this Y component in this circular manner. So can you check the changes? So actually this coordinate system like placed on this circumference, I don't want it. So what I do, I simply go to, maybe I'll increase the size. So what it is saying by geometry selection. So I selected the outer periphery, but it doesn't work for me. Maybe I'll hit control and I'll select one circle also. So let's check whether it has helped. No, still my maybe I'll select the method. Instead, I'll go with global coordinate system. Let's check. Put 0, 0, 0 over here. Yes. So now my coordinate system is exactly at the origin. So this is my cylindrical coordinate system. I just right click and say rename. Let's put cylinder. So this will be my cylindrical coordinate system. Now just come on to this rotational velocity. For that, already it has selected all bodies. So all bodies is nothing but we only have one body. Now I have to define the magnitude. So our value is 80. Correct. Now uh, let's uh, define the axis. So here we can have, or I think I can define it directly by using maybe like this. Let's check. No. Okay. Even I can define axis by using this face also because it is directly taking when I click on this face, it is directly taking the z axis. You can see it over here. But the coordinate system which I defined, maybe that will be required in case if you need to extract the reactions, right? So maybe this is for your information, so you can define both coordinate systems. So here actually it has worked. So I do not need to have a separate coordinate system, or so I can define it in terms of components also. Fine. So I have defined the rotational velocity. So you can give it either like clockwise or anti-clockwise. For anti-clockwise direction, you can simply put minus 80. So it will have like results in opposite rotational direction. So now just click on the solution and say solve. Okay. So I want similar things. So I just drag it and drop it over here. So now see, in boundary conditions, need to select fixed support. You know why this has happened? Because whatever I dragged it from here, so this fixed support was nothing but it was from here. But now I want results for this fixed support. That's why it went off and it was just showing in like yellow color to me. So I just redefined it. I want results on that fixed support. So you can see it over here. So I just evaluated the results. So here I am having the reactions. So maybe you can compare the reaction forces. My total reaction force here is 3 into 10 raised to 5, and maybe in other case I'm having little bit somewhere around the same. So I do not have that much impact due to my rotational speed. But yeah, this value also has a lot of impact on it. Maybe if this value you can increase, you can see the change here in the reaction. Maybe you can see the changes or differences here in deflection, current stresses. Fine. Maybe if you can increase rotational velocity a little bit, you will have a noticeable difference in the results. Fine. Okay. Sorry for that. So I think now we have completed our first problem for the day. Okay. We have only three participants. That's fine. No issues. So now, moving forward and going into the very important topic. So is bar roll cage and yeah, assuming various cases. So let's just save this first. Maybe some results have went off. I'll simply save it. Okay. And now just read out first the problem statement, what it is. So here we have front roll load analysis during vehicle undergoes a front roll load. Okay. Total force to be applied 10,000 Newton. Apply force at an angle of 45 degree on front member. Okay. So what is the front roll over condition is, if I'm having some load, maybe someone sitting over here, and my this roll cage, or just assume that a vehicle, it's moving forward. So that is nothing but my this case. So here actually I'm having suspension mounting pads. So wherever I'm having suspension, like front suspension and rear suspension, so those points I will need to fix. Means there I will have constraints, and whatever this force due to maybe a passenger or maybe a velocity moving forward, uh, that load I will apply on one of the front members. So somewhere over here, and that too at an angle of 45 degree. Until now we have seen forces. So we have only applied forces in the direction of x, y, or z, but now we will see how we can apply the force in maybe angular way at 45 degree. Okay, so this is a 1D analysis. So what we saw for this disc brake, it was two-dimensional one. So this will be one-dimensional one. So here we need to define the cross section and cross section dimensions. So that data we need to define. So let's just go to static structural again. So here I will just write problem number one. So I'll check the material. So nothing has defined. So I'll consider the default material as structural steel. Just go to the design modeler. So there we will import that 1D model. Select any plane. Just check the units. Shift it to now. I'll go to files. Say import external geometry, and we'll just go to the assignment mod. Fine. Now I simply say open. Here now if I just click it on import, so here you can see line bodies. So here by default it is no. Means if I generate it also, I will not have my part over here. So just go to right click, say edit again. So you want basically line bodies, and your model only have line bodies, so it doesn't have any surface or solid body. That's why just make this S and say generate. Then you will see your 1D model. So 1D basically means you only have lines present here, right? Now your first part should be to define a cross section. So how you can define? We have already seen this method to define a cross section. Just go on to the cross section, but before that, just check what cross section we have over here. So maybe just come down or up. Yeah, here you have outer diameter. they have they are saying that diameter means it's in circular way. Okay, again it has defined thickness means it has some diameter and some thickness means it's a hollow diameter or hollow circular cross section. Fine. So okay, 24.5 25.4 millimeters is my diameter. So just go on to the concept and cross sections, and this one circular tube or basically hollow tube. Fine. Now 25.4 millimeters is my outer diameter, 25.4 millimeters, and 3 millimeters is my thickness. So just go and say 22.4. This is nothing but my cross section. Fine. So I have defined the cross section. Now I need to assign the cross section to all the parts. So I simply select one, press Shift key, and select last one. So everything in between will be selected. Just select and say circular tube. So now cross section has been assigned to everything. Now, the very important. So all I'm having here 37 parts and 37 bodies. So for ants is basically it has 37 different bodies. But for me, if I'm seeing I'm having like these bodies connected at some portion, but ANSYS doesn't know this. So for that, to let ANSYS know that this is a single body or these junctions are welded at this location. So we have to do, we have to just right click and say form a new part. Now you can see instead of 37 part, now here it has mentioned only one part, and in one part I'm having 37 bodies. And here you can see shared topology method edge joint. So wherever I'm having any joint, some maybe somewhere here, so there my topology will be shared. Right, basically in practical or in reality those portions will be welded together. Fine. Now my part here in design modeler is complete. Now I'll just move to the ANSYS mechanical. So just double click on the model. So I'll be into the mechanical. Okay, so I'll check my units, the fine. So structural steel, my material cross section is 25.4 millimeter with 3 millimeter thickness, means inner radius will be 22.4 millimeters. Okay, it's inner diameter. Sorry that I said inner radius. It's diameter, but notation is RO and RI. Fine. So now, so just right click and say generate mesh. So your all line bodies has been meshed now. So all these elements are one dimensional elements. One dimensional means they only have element in axial direction. So they do not have anything in like other directions. So maybe if you consider this in x direction, so they do not have anything in y and z direction. Right. So element is only in one x direction. Now most important step over here. Maybe I'll go to tools and uh, sorry, views, Windows, and say reset layout. So this step will be very important and helpful for quick, model setups in future, in case of such bulky problems. I'll say so. Here, actually, you need to select multiple points, maybe just for your application of boundary conditions. So let's, if you check it over here, maybe 1, 2, 3, 4. So these 8 points you need to select again. 8 points at maybe 6 points at rear suspension. So these points you need to select every time if you apply load or maybe any fixed support, something like that. So here you have one option, so you can make some named selections. So only you need to select it once, and you can use those selection for multiple times. I will show you like how you can select. Maybe just go on to here. So here we have seen we have vertex selection, we have line selection, face selection, and body selection. So all these options we have seen. So here we have some more options. So they are like node selection, and second is element selection. Correct. For node selection, you can simply hit shortcut like Control and N. So you can go into that menu directly, and you can, if you go over here, so you can select basically any node. So whenever, wherever your cursor goes. So now I just hit node selection. So I go over here. So here basically I will have only one node because I have shared the topology. So I simply check where I'm having that node, or I can do I can just have box selection and I can do like this. So yes, my this node has been selected. Correct. So now I'll hit control. I'll select one more over here. Let's see which nodes I'm having. So one, two, three, four, and same nodes on top member also. So I'm having these two. So I'll again select it over here. So I'm selecting it with the box select, right? So I have selected four nodes. Got it. Now I have to select those here also in top side. So I'll select. Fine. So you can see it over here, 8 nodes selected. So now just right click and say here, create named selection. So I just selected all the nodes by pressing control key, and afterwards I just say right click and say create named selection. Okay. So here what I'll rename it as front mounts, and I will just tick this point because now I have selected nodes. I can select here anything. I can select basically face. I can select here some edges or maybe vertices. I can select, but here now I have selected nodes. That's why I tick this apply to corresponding mesh nodes, right? And say OK. So here, as I say OK, this in name selection, you will have this window popping up saying front mounts. So whatever I have selected now, you can see it over here very precisely. Correct. If I go to edge selection, so I cannot select, or maybe if I go to vertex selection, I cannot select any vertex because this is my full member. This is my full member starting from this point to this point. Here with this vertex selection, I can select only vertices like this one or this one, but I cannot really select the middle ones. Those are my nodes. That's why I have done a nodal selection. Got it? Nodal named selection basically. So this is one way, and if I do not have to select these middle ones, so there also I'm having one more option. Maybe this is just for your information. Maybe in future if you need somewhere, so in that case what I will do, I will simply select the edges. So maybe these four edges, and maybe I'll right click over here, or maybe I can right click on this name selection part also and insert and say name selection. I can add this, but you can see those are vertices and not nodes. So nodes, you can see those are in pink colors, and now I have selected the vertices, so those are in black color, right? But I can convert them into nodes. So how I can convert? Just come over here, say right click and say create nodal named selections. So what will happen if I do that? So you can see selection 2. So they are converted into the nodes now. So there basically I'm having nodes, but by this method I cannot select like in between nodes, because what I did, I like at first I selected a vertices. So four different vertices I selected, and I only changed wherever I am having that vertex. I just changed to the nodes at that vertex. Fine. So this is one method to select nodes. now I'll delete this. So this was only for your information. So our point of interest is only this one. So where I'm having like some middle nodes. So same thing I'll do for this uh, rear mounts, or maybe real suspension mounts. So these one. So here I'm having 1, 2, 3, 4, 5, 6. So 6 mounts I'm having at back. So now what I will do, I will again go to mesh, because the middle nodes, those will be visible only when I go to the mesh. If otherwise I will have only this line body and I cannot select the midway nodes, right? So just go back to the mesh. Again, click on the node selection. Okay. Now click, just go to the box selection. It will be easier to select the nodes. One I have selected, hit control. Two, just press the middle scroll button just to rotate this. I have selected three, four, now somewhere here. Fine. So what I did, I have selected four different positions. Now simply right click and say create named selection. In create named selection, as we have selected nodes, that's why just click on here, apply to corresponding mesh nodes. Fine, and say OK. And simply right click it over here and say rename. I'll say rear mounts. Fine. So what we have done until now, so we have selected the location. So this part is a little bit new for today. So name selection. So why I did this, because yeah, you will come to know this why I did this, because we have multiple calculations and we need to use these constraints as it is. So just to repeat every time this selection, so the best way is to make named selection, so it will save your time, or I'll say it will save your modeling time. Fine. Now just go on to the problem again. So I have made these changes. So I only have one boundary condition over here, which is, or one load over here is 10 kilonewton, that too on front member, and at angle of 45 degree. Okay, fine. So what I'll do now, I'll click it over here, say insert and say force. So this is my front member. So now I go to single selection. I go to edge on this edge. So this is nothing but my front member. So there I am having a force. What amount? 10,000 Newton. So now you can see its direction. So it's somewhere here, but I don't want that direction. What I want it to be in 45 degrees. So what I just do, so again, there are multiple ways to define this. So one way is to just get this line. So I'll define my force in this direction. So just click on this direction, click on this edge and say apply. So can you see now? So this force is at some angle. So it is not in the direction of X, or not in the direction of Y, or not in the Z, but it is at some angle. So that is one way. And second way is, so just change method by defining by vectors to components, and you can check. So my this force will come in my ZX plane, right? ZX plane. So I can resolve my force. What basically I'm having force 10,000 Newton. So simply I will do 10,000 sine 45 and 10,000 cos 45, sine and cosine. So if I make this, I can simply enter my force values here in X and in Z. So ultimately it will give me a resultant force at a 45 degree. So what I did, I simply resolve this force in X direction and in Z direction. So for Z, I need to define minus, like minus cosine of 10,000. So by that way also you can define, right? So I'll go to vector again. Let's make a 10,000 and this direction, say apply. Okay, so now I have applied force, and now the fixity or the constraint I need to give. So basically, I'm having constraint at front and rear. Both sides I'm having a constraint. Let's define it. But now, as I'm having constraint on nodes, so our general fixed support. So whatever we were using until now, so fixed support on vertex, fixed support on edge or face or body. So now it will not work because we have to fix now nodes. So that's why we have again here nodal displacement. We have option of constraints on nodes. So nodal orientation, force, displacement. So these options I am having. So here what I will do, I will choose this nodal displacement. And now what I will do, I will choose front mounts and simply say 0, 0, 0. So I just fixed these nodes in X, Y, and Z direction. Basically, I am defining fixed support. Fixed support means what? My support is fixed in X, Y, Z direction. Right. So same thing I am doing over here, but by using displacement constraint now. Okay. So I did it for front mounts. So same thing I will repeat for rear mounts. So go to the nodal displacement. In name selection, just select rear mounts. Just hit 0. Here also 0. This is 0. So I have defined the constraints and I have also defined the force. So all my boundary condition application is done. So I simply say solve. Okay. Now let's check what is happening. So I think first time we have encountered such type of error. So here something is written as okay, degree of freedom at node 80. This is usually result of ill conjugate matrix. Okay. So it is saying me that something is moving. So and that is beyond my limit. So we can have a first remedy on this. Just go on to the analysis setting and make this solver pivot checking off. That should be our first remedy, just to know whether we can solve it or not. So you can come across such warnings or errors when you just check it, and yeah, you can see it. So this just went off because what was happening, because of the load which I have applied, my member it is deforming, and my that deformation is beyond my set limit. So that's why it was giving me the warning or error that my body is deflecting. Basically my nodes or my elements, they are moving. So that was my error. But now as I made my pivot checking off, then I solved this. Okay, now just go say insert. Now you cannot see the stresses because I haven't make my beam section results to S. So I simply say it to S. Now right click and say equivalent stress. Second is insert deformation. Fine. So you can see it over here. Can you see like how this member is deforming? That's why it has given me error that your deformation is more and it's beyond the limit. Correct. So this is my equivalent stress and these are my deformations. So you can see due to application of load here that to in 45-degree direction, my these parts they are also deforming. Even though deformation is very less, maybe in not even in millimeters, less than 0.5 millimeters, but still maybe here you can simply go to the true scale. There you can come to know I'm having some deformation here. So what should be your conclusion or maybe action on these results? Your action should be maybe you need to reduce, if you need to reduce this deformation, maybe you can add one of the member over here or maybe somewhere here. So that should be your action if you see such kind of results. Or if you can see equivalent stress maybe 80 megapascals and that to maximum it's somewhere over here. So what should be your conclusion on this? Maybe if I need to reduce these stresses coming onto this member, maybe you can add one more member over here, or maybe somewhere here, that you can do, right, to reduce the stresses coming into this. Or maybe your remedy should be just increase the diameter or increase material here, so which will have my reduced equivalent stresses, right? So such thinking should be there when you do such type of calculations. And these are only for your improvements, or maybe improvements or your of your such kind of bar competitions. Right. So I think we completed the first one. Now we have same model again. So we will not create the second model, but only here we have changed boundary conditions. So I'll just read out what those are. So first, front torsion analysis during vehicle undergoes torsion at front force. Front, okay, torsion at the front and force to be applied on front left suspension and right suspension. Okay, so basically, my vehicle will be observing a torsion. What torsion means? Means let's consider I'm having like front two wheels, and one of the wheel is observing upside force, and one other wheel opposite to that is observing downward force. So that is nothing but my torsion case. So both the front wheels are observing some loads but in opposite direction. So that is nothing but my torsion case. So now I have to apply 1000 Newton in for left suspension in upward direction, and 1000 Newton for downward direction for right suspension. Right, and my rear suspension will be fixed. Okay, so now let's go here again. Just drag and drop a static structural portion onto the model, because I have same geometry, I have the same material, and I have same mesh size. That's why I just drag and drop it over here. So the only change will be in boundary conditions, right? So just a moment. Now what I need to do, my rear nodes are fixed also here. So I just drag it and drop it. So I have applied one boundary condition. Now for front case, for left side I'm having vertically upward load, and for right side here I'm having vertically downward load. So just let's just apply that. So here I need to apply nodal force again, because I want to select mid side, somewhere in this middle location. These nodes I need to select, but now I do not have name selection. So what I can do, either I can just go here in the named selection and maybe make one, or maybe I can simply maybe use the force applied on these members instead of nodes. So that I can do. Let's just do that maybe. So on these two members, I'll be applying load that is 1000 or 10,000. Let me check. It's 1000. Okay. So 1000, and in I'll make it like component wise and in Z direction. Right. So my force is applied in upward direction. So same thing, maybe I can duplicate this. So instead of these edges, I now select the edges from right side. Just hit Control and select the edge and say apply. So two edges I have selected, but now I don't want force in upward direction, but I want it in downward direction. So I just put minus sign over there. Got it. So you can see it over here. So this is nothing but my rolling condition. So torsion condition. Sorry. This side I'm having, and in other side I'm having load in downward direction, and my all like rear mounts, they are fixed. Fine. So I just say solve. So same results now I'll extract. But yes, again in analysis setting I need to go to pure setting and set it to off, and Here in solution, I need to make S for that beam results. Just say solve. Now I want same results like equivalent stress and total deformation. So that I can just drag and drop it from my earlier calculation. So here you can see because of now torsion, I'm observing some stresses here. So, but stresses are very small in the range of 30 megapascal. And deformation, let's check the deformation. So from here I am applying top upward load, and from right side I am applying downward loads. So the dominating factor is the upward one. That's why I'm seeing over here some more deformation. Can you see? So it's 2 millimeters, and right side comparatively less. I will not say like a very big difference, but comparatively less than this one. Okay, near about same, but yeah, those are comparable. Fine. So we have completed the second problem now. Just check what happens in this third one. Okay, now front bump analysis. Now, if my vehicle come across any bump, a road bump, so how it will behave. So for that, actually, here we need to simulate that case. So now in on front suspension, I will have this much load. So that too in upward direction. If some bump comes below my vehicle, so it will exert some load from my bottom. So that is nothing but 2,500 Newton. And yes, other things remains the same. So now what I will do, I will just go back. Maybe I can drag and drop again static structural somewhere here or here. So both cases are possible, and here I'll simply enter into the solution. So I can set it to off at start itself. Now I have the rear suspension which is fixed, so I can simply drag and drop it. So my rear suspension is fixed. Fine. So now for front suspension, I will be having vertical load. So what I will do now, I will go to the nodal force because I'm having that front mount selected. So I just go to front mount, and here by default it has given me component wise load application. So in Z direction, I will apply 2,500 Newton. So as this is nodal force, maybe you cannot see visually that load, but I have applied it 2,500 newton. So this is nothing but my uh, displacement constant, which is my fixed support. And on the front side, due to the road bump, I am observing this much load in vertically upward direction. Okay, I will just simply make this beam results on and just say solve. Okay, so simply take drag and drop it over here. I will have the results. So can you see due to bump what's how amount of stresses I am having? So you can see it over here. So you have, maybe I simply go to undeformed one. So you have a lot of stresses occurring in this beam in case if you this vehicle is moving from one of the bump. Maybe deformation if you need to see. So see the deformation how it is. So around 82 millimeters due to only single force, that too in upward direction. So my this portion is fixed, and this part is still at the it is observing some load. That's why I'm having this much deformation. Okay, so I think we have completed this bar problem, bar roll cage basically. So second will be go-kart roll cage, and I think here also same concepts are there, just selection of nodes. So exactly similar to this, exactly similar to the one we just calculated. So here maybe I can simply explain. We will not going to solve this because we have one more problem. So maybe we can take that. That's interesting. And this is simpler one. That's why I'm dropping this. So due to our time constraint for today, as we have joined like half an hour late, so here you can simply select these two nodes. By either way, you can do this because I have only 2 points. So either you can select by vertex method and then convert it to nodal selection, or you can directly go into mesh and select directly a nodes from that mesh. By both way, you can do it. So these are my like rear suspension mounts. These are my front suspension mounts. And in this case of collision, this 4,000 Newton basically you will apply on this front side. So this front member. So that will be one of the case. In second case, you will have impact from left side. So in that case, you just apply this force on one of the left member. So this member, you can apply force in this direction, like perpendicular direction. Okay, and all other things will remain same. And in this third case or last case, so there will be collision from back side. So in that case, you will simply fix these four nodes, and you will have on this rear four beams, or maybe just bottom one beam or bottom member. So there you can apply this amount of force, that to perpendicular direction hitting to my vehicle. Right. So that you can do. Let me check. I heard some sound. Okay, now we will be moving to this calculation. So there we have again three different problems. So let's see what it is. It's supra cage, and what problems we have. Again, we have 1D elements over here. So same thing we will be doing over here, like front impact analysis during vehicle undergoes collision from front. So this is one case, and even in second case undergoes collision from side and collision from backside. So same three cases are there. So I'll simply go to this one. Just go to static structural. Just double click it. Okay. So my static structural window, it has come up. So I'll write Supra. Fine. So I'll right click on the geometry and say new design model. Okay, I click on one of the plane, just set my units to millimeters, and just say apply or import external CAD geometry. Go to the assignment number 2 and say Supra model. Okay. Before generating, just click here. I want line bodies, so say S and say generate. So this is nothing but my Supra model. Fine. Now here I am having 30 parts, and I do not have any cross section assigned to it. Just go to the concept, say cross section and circular tube, and let's check the dimension of that tube. So 25.4 millimeters. So same one. So 25.4 millimeters, and this one is 22.4. Got it. Think here it's my radius basically. Mhm. One point actually here to note, as I seen, maybe I can simply do one thing over here. If I need to, I cannot basically add any dimensioning plane over here. But as I see over here by using this ruler, so those are nothing but uh, my radial values. So if I just check Ri 22, so maybe if I zoom it, so you can see it from my center point to this one. So this is somewhere around 25.4 millimeters. So one thing is clear. So these are my radius. Uh, so I want actually this as a diameter. So I can do one thing. I can simply say is equal to, and then say divided by 2. Okay. So it is saying maybe Invalid dimension value. I have to maybe define one by one. So I simply make it, just go to the end and set 2. Now it has defined 12.7 for me. And now just go over here, say 12.7 minus 3 millimeters. So you can do that algebraic calculation directly here by putting is equal to sign. So this is nothing but my exact cross section according to this problem. Actually, we did in last problem, we used directly diameter values, but one correction here. So these are radius, not diameters. So earlier I thought it's diameter, but no. So you can see by comparing. So I am having this ruler, and here you can see now. So my diameter is somewhere around 25.4, right? Okay. So I have defined the cross section. Now I just select one, just press shift key and select the last body, so that my all bodies will be selected. Just go there and select the cross section as circular. Now I can see I have 30 parts and 30 bodies. I need to bond them together. So I simply right click and say form new part, so that I will have one part and 30 bodies. So what ANSYS assumes over here, wherever I am having this edge joint, and that will be welded together. Right. So my part is complete in this design modeler. So just double click on the model, so that we will enter into the mechanical. So we are into the mechanical now. Okay. Just check material, that's fine. Cross section dimensions, they are also fine. Okay, right click and say generate mesh. Oh, I'll go to view windows and say reset window. Okay, so I'm having such kind of model. Now I have to make named selection. So let's see where I'm having these mounts. So front side I'm having 4 and 4, 8 mounts, and back side I'm having a rear side I'm having 4 mounts. Fine. So let's just go to our model. So this is my front side. So I'm having one mount to somewhere over here and here and here. So I'll go to the node selection. I'll go to then box selection. I'll select one, hit control key, select second, third, and fourth. Alright, so same way I'll do for right side, one, two, this one third, and this one fourth. So I have selected it total 8 nodes. So simply right click over here, say create named selections. As I have selected nodes, that's why tick on this box, say apply to corresponding mesh nodes, and say OK. So name selection it has created over here. Just go there and right click and say front mounts. So I just renamed them, and on rear maybe we'll just go back again to the mesh. So on rear I'm having again 4 locations where I need to have those mounts. Just check it again. So somewhere over here, I think I do not have the middle member present. Or is this the case like this? I think we have made wrong selection. So here I'm having only 4 nodes instead of 8. So maybe let's just go back and make it. So this is my rear side, not the front. So just you can also make changes over here. Instead of this, simply what you can do, you can click like this. So here you can see at bottom. So this is vertex. I don't want vertex. I want node. So just click here. Just click one. Again, press control. This is 2, 3, and this is 4. Say apply. So my earlier selection goes off, and now I have selected only 4 nodes, and these are my rear nodes. Let me just make that correction over here. Say rear mounts location. Fine. If you click on this, you can see those nodes, right? Now just go here, and now you have to select for front side. So one, just press Control, two, three, four, and four on the top. So here one, two, three. So by mistakenly I have selected two. So now just go to single select and click on that node again. So it will be deselected. This one. Just right click and say insert name selection. So now you can see I have 10 nodes, right? Now, so I have selected for front, I have selected for rear. So just right click and say rename and say front. Fine. So I have done name selection basically for constraints. Now just check the boundary condition. So one is surely the fixity at this nodal selection. Second is the front impact, and which is nothing but my 6 kilonewton and collision from front. Okay. So let's just apply first fixed support. So I'm having nodes, so I'll go with nodal displacements and maybe a rear mounts. So I'll simply define 0 in XYZ direction. I can just duplicate this and I can change rear to front, and I will have like these front mounts uh, fixed. Okay, now I'm having collision from the front side. So how I can define that? I can simply define force, and now I can define that force on the members. Maybe I can select one, hit control, 2, 3, 4, and even this one. So all these members, I'm applying a load. So you can see I will apply it by using component. Let's check in Z direction will be the direction. So it will be 6 kilonewton. So can you see it, the load? So which is nothing but my front collision, right? Now here just check on beam results, say S, and analysis setting, maybe I'll make it off itself at first and say solve. Okay, so my analysis gets solved. Just right click, insert, and say stress, and maybe total deformation. So let's evaluate these results. You can see, so I just make this to true scale. So this is nothing but my equivalent stress which is occurring. Maximum is on this middle member, right? If you think the stress value is much more, you can maybe add one more member in such cross direction, or maybe you can have these members, or maybe increase diameter or increase thickness for these members to reduce this equivalent stress. So that must be your design changes in order to reduce the stresses occurring in this component. And deformation you can see in this top member, maximum is 0.3 millimeters, so less than 1.5 millimeters. So I'll say deformation is good, so it's less and it's in the range. Now we will check what next case is. Yes, so next case will be impact from side, left side basically. So yes, we will have similar kind of analysis, only impact direction will be this side, like perpendicular from left side. And again same constraints, front and rear suspension mounts, they will be fixed, and similar kind of output we need. So what I will do, instead of creating new model, I simply drag and drop static structural on the same model, because I will have here same material, same geometry, same cross section, and even same mesh. That's why. I'll simply rename it as 2. Just go double click on it. Uh, Make this solver flow checking to no or off. And second is in solution, make it S so that I'll get my beam result. So I have these two boundary conditions exactly similar. So I simply drag and drop it, and force also. But now I do not have force on this member. Instead, I am having it from left side. So what I will do, I will try, maybe I will add this force on these members. So this is my left side, and maybe I will add load on this, this, and this. So on these members, I will add the load. Fine. So what I will do, I will simply right click, insert, and say force. As I have applied it on the members, that's why I can select force. Otherwise, if I would have applied it on nodes, then I must use nodal force, right? In case if I am selecting nodes and applying force on it. But now as I have applied it on these edges basically, or on total member, that's why I can apply it by using this force command also. Okay. Now the value of load is again 5 kilonewton, and I should define it in the direction of x, which is nothing but my side impact. Okay, you get it. So I simply drag and drop this before I'm solving. I simply say right click and say solve. So here now I will be having the impact from left side. You can see maybe I can have auto scale. See, due to the impact, what is happening? So my these members are they are deforming. Let's check the equivalent stress. So my equivalent stress, you can see it's going beyond 160 MPa, 160 megapascal, and maximum is occurring on this say like joint, right? So your remedy should be on this. Maybe you can add one of the horizontal member here, like joining this junction to this junction. So it will reduce the stresses coming over here. So this should be your thinking after seeing such kind of results. So to reduce maybe high stresses or deformation. Got it? So we have solved here the second case. Now in third case, now my impact is from backside. So again, I'm having same constraint. So my front suspension mounts, back rear suspension mounts, they will be fixed. Only change is now my collision will be from backside. Assume that any other vehicle comes from back and hit to my vehicle. So that will be the scene. Okay. So again, I'm having the same model, same cross section, even same meshing, everything. So I just use the same setup again. So only drag it and drop it over the model. So everything above that, like a row above the model row, will be shared. Fine. So I go to setup again. In analysis setting, I simply make this pure checking off. In solution, I make it S. I have these two nodal solutions exactly similar, like front and rear mounts, they are fixed. So I only have one change now, that is force. So I say insert and apply force. So now my force will be applied on 1, 2, 3, 4. I just hit Control key and selected that 4 edges, and that there I have applied force. So now see my z axis is pointing in like right direction, so maybe here, but I want its collision, so I want load in negative z direction. So what I will do, I will simply change here from vector to components, and in z I will mark as negative 2500 newtons. Can you see this load? So this should be in this direction, so negative z direction. That's why I have added minus sign over there. You can see in the here they have mentioned 2500 only, but it's as it is from rear side. That's why I have applied, I have made it's I have changed the sign and said minus 2500 newton. Okay. So just right click and say solve. So same constraints I have used, like front and rear mounts I have fixed, and only changes in this force. So now maybe I can apply stresses and can apply the deformation. Now maybe I will look deformation in Z direction. Let's check. So you can see stresses. They are very well in below my range because of the supporting members. Now just check the. Okay, so this is also, I'll say, very small in the range of zero point 0.9 something, 0.09 millimeters basically. So very good actually. We have that, and here somewhere over here I'm having the maximum value. Maybe I can just take a probe and just point it. But you will say that this is like negative value, minus 0.3. So why this is in negative, like why sign is negative? Because my Z, you can see this is pointing in rightward direction, and I'm having force in like exactly reverse direction. That's why my this body, it is deforming in negative Z direction. That's why I'm having negative sign. But deflections are never been negative. So in reality, the deflection will be zero point 0.3 millimeters. Right. So minus sign is only showing here direction to me, that it is deforming in minus z direction. Okay. Got it. Uh, Maybe if we have, okay. So I think we are done with the all calculations for the today. I know like today we actually skip one problem, this one, but this is very much similar to first and second one, and yeah, you can do this. So as we have time constraint for today, if we would have joined exactly on 8 p.m., then we would have surely taken that problem too. But yeah, whatever we solved today, if anybody has any question until now, maybe we can discuss those now. I think we are only two left. So if we have any questions, then you can ask. Otherwise, maybe we'll wait for 2 minutes. So meanwhile, I will simply check what is there for us for tomorrow. So not this one, this one. Okay, so tomorrow we have composite analysis of cockpit. Again, composite analysis of fan blade. Fine. Oh, contact analysis. Nice. So tomorrow we have very good topic of contact analysis. So now you might have observed now our difficulty level is going on increasing. So first session, you remember first, second, third session, we started from our basic calculations, and today now what we did, we even made some nodal selections. Even like last two sessions, we made we used like multiple calculations or multiple system calculations or custom systems calculations. We have seen thermostatic calculations, means we took steady state thermal cases. Again, we took those results, and we done calculations for static structural part. So you can notice like our difficulty level is little bit increased now, and as you got like more familiar now, so here you will have again some more in-depth calculations, so which is nothing but contact analysis. So here I'll show you like how we can define contacts, how we can model those contacts, what are different types of contacts, and why these contacts are necessary in our calculations. So maybe we will discuss this, because there is a lot of things to learn in this topic, basically contact analysis. So now we will cover this part tomorrow. Let's see how it goes. So yes, I think we, as you are not saying anything, means I assume that you understood whatever we have seen today, and you do not have any question. Is it so? So I just want genuine feedback, whether you understood everything today. So maybe we are only two over here, so you both can unmute yourself, and maybe we can discuss for 5 minutes. Those are left. So this is general talk. So how was today's session, and like have you understood it? Or yes, yes.
Yep.
But like when you try it, maybe on your machine, or maybe you will come across some doubts or some queries. So that's why I insist, like try to install Ansys as early as possible on your systems. And maybe if you come across any doubts, you can ask me, and I'm here to solve those doubts. Okay, okay. So yes, so let's. I think we will conclude for day. And just one tip, maybe while practicing, if you need any assistance, maybe I'll show you. There is, if you go here, here you have one menu help. So when you just click on that, you can go into mechanical help. So whatever you need, maybe a nodal selection. There you can simply type it over here, maybe nodal selection. So if you type it and just say search, you will get n number of results. Just you can go into it. So applying nodal selections via the toolbar, how you can do that. So anything you can find out from this search menu. So just go on to help and just click it on mechanical help. So everything you can get it over here. Maybe you want to apply force or maybe apply nodal displacement, so you can simply go to this help, just type this word nodal displacement, so you will basically get how you can apply it. So all things you will get it over here. Fine, so this is just I'll say tip for the day. So yes, thanks for bearing me for the last 1.5 hour, and yeah, I'll say a good night, and yeah, see you tomorrow.
Thank you, sir.
Welcome, welcome. Bye.